So you have been building ML models, but the only concern you have right now is how do I get my model to access through a public API or something, even as a private API or something else. My ML model does not work on other machines. My ML model is stuck on my local, and I cannot transfer that information stored in my model to other people through any kind of API or through any kind of URL. How do I do that? In today's video, we are gonna see exactly that. So I hope you guys gain some knowledge through this video. And if you do, please hit that like button and subscribe to the channel for more such content. This is Atharva from Pi Analytics. Let's go. Okay, welcome to the tutorial part of this project. So now, what I'm gonna do is take a basic ML model. So I'm just going to take this diabetes model for API Jupyter Notebook, and through that I'm gonna save a .sav model that will predict if a person is diabetic or not. I have worked with this kind of model in the last video also. If you need to check that out, in that app, in that video, I have deployed the model as a Streamlit app. Today we are going to see how we can deploy the same kind of models or any kind of models to be exact as a public API through a URL, even if it is a local host or even if it is a public URL. Doesn't matter, you can do both of them. I'll show you how. We are going to do that through Ngrok. What Ngrok is? Ngrok provides a public tunnel API, like a tunnel basically, which provides a public URL for you, for your model to be exact, in order to exactly access your model through that URL. I'm going to show you how we can do that. Before that, let's just take a look at the diabetes model that we are going to work with. Firstly, what this model states at it takes diabetic dataset which has columns like pregnancy, glucose, blood pressure, skin thickness, etc., insulin, BMI, or the pedigree function value, or lastly age. Total 8 columns. Lastly, no worries, if you are working with your own model, only the parameters will change, only the column names will change, only the field names will change, nothing else. Okay, so now let's move forward. As you can see, I have worked with some I have did some data analysis, like getting the shape, describing the data, and through which getting the value counts. Lastly, then getting them mean, grouping them by the mean of the outcome, and then dropping some columns, then again doing some extra stuff. Lastly, separating these sets into training and testing split. Okay, and then training an SVC classifier on it. What does this SVC do? It will help us differentiate between if a person has diabetes or if not. Okay, so I hope you guys get what this model actually is and what this project is all about. Lastly, this is the prediction system that we are going to work with. Now take a look at this code precisely and very carefully. What first are we going to do? First, we are getting a tuple. It can be any kind of data type actually. It will get converted to a NumPy array using the asArray function of NumPy, and then we will get the reshaped, we will reshape that data as a column through calling the .reshape 1 minus 1. And then we are going to take a prediction using the predict function of the classifier, and then if that prediction first value is 0, like the 0th index contains 0, it will state that the person is not diabetic, or else the person is diabetic. Simple as that. Okay. Now, lastly, we are saving the trained model through Pickle. Now, what Pickle does is it serializes the model and also deserializes. I'll show you when I load the model through Pickle in the next in the next Python Jupyter Notebook. Okay, so We are saving this model as diabetes underscore model.sav. The SAV format is because of the model being related to a scikit-learn library. So that's why we are going to use the extension SAV. Then we are going to save that using pickle dump. And then we are again cross-verifying if the loaded model is working properly through the pickle.load. This is deserialization and this is the serialization. I hope you understand. Okay. And lastly, again, the same thing that we did previously. And as you can see, the person is diabetic. This is the analysis while loading the model. And the original model also says the person is diabetic for the exact same data. As you can see, the 5166, etc. And lastly, here also the 5166, etc. So as you can see, the model is working properly and we have also cross-verified everything. Now we are going to move towards the making of the ML model. So if I come to the files part, I have my data set, and again I have my saved model, the diabetes model.sav saved here. What I'm going to do is download it, store it in my local machine, open a second Colab notebook and load it there. Nothing. That's it, what you're going to do. That's something you have to do because you're going to make an API for that model, which will be taking all the details of that model from this .sav file. So yeah, that's it. Now let's move forward and start writing code. Now for this exact project, what we are going to need is FastAPI to make APIs, for example, API apps to be exact. So we are going to use FastAPI in order to get the API apps running in Python. That is done using FastAPI for ML models to be exact. Then we are going to use UVCon to run the API app continuously without any interruptions. Or you can also use Gunicon, but it depends on you. I prefer UVCon. Okay. So then again we are going to use pickle 5 in order to deserialize the model. Then we are going to use pydantic to define the data types that we are working with. Pydantic allows us to explicitly define the data types. I'll show you how. Then we are going to use scikit-learn because we are going to use the .sav model, which will require scikit-learn to be exactly ran into a machine, or in this Colab notebook to be precise. Okay. Then we are going to use requests. What request does is it will allow us to get post requests to our models API, and yeah, that's it. Lastly, we are going to use PyJSON because the model will give us the results as JSON, and we are going to convert them into the, we are going to convert that into text, the normal text, and then we are going to use Ngrok, as I said, in order to make a public URL for our API, and lastly nest async.io to make this app asynchronous. That's it. Okay, so now we are going to install everything that we need for this app. So we are going to use something like this. Okay, now what we will need is I'll do it like this: pip install, and now we will do it. Alt down. First we will need FastAPI, then we will need UVCon, then we will need pickle 5, then we will need pydantic. Okay, I hope I spelled it right. Yeah, pydantic, then scikit-learn, then requests, then PyJSON in order to convert everything as JSON, then Ngrok, okay, and then nest async IO. Okay, that's it. If I do run this cell, it will say requirements already satisfied, because for the testing I've already done that, and it was already installed that time. So yeah, okay, so everything will be satisfied for this one. We will just wait until those things run and until everything is done. Till that, what we are going to do, I will allow you to go to dashboard.ngrok.com and get yourself an ngrok authentication token in order to run your app using that authentication token, because you need a verified account in order to get access to that API tunnel. Without it, you can't do that. So yeah, just go to the tunnel agent authentication tokens, go to auth tokens, add a new auth token, then save it. I will just cancel for now because I have already created and I have already saved it. Okay, and that's it. What I'll do is I'll go to the AI assistants, and what I'll do is hide those. I'll disable Gemini, and I hope that should work fine. Yep. So everything is now satisfied already. Now we will define what we need for this app. So we will import everything. So import FastAPI. Sorry. So from FastAPI, we will import FastAPI. So basically the indentation or the capitalization is case sensitive, that's why. So now from Pydantic import the base model. Okay, then we will import pickle, then we will import JSON, then we will import UVCon. You can also use Kunicon, as I said. Okay, then we will import from ngrok. We will import the ngrok module. Okay, and then from course. What course is? It is the middleware of the FastAPI that will allow us to make FastAPI apps. Okay, so from FastAPI, I hope I spelled it correctly, dot middleware dot course, I think, yeah, import course middleware. Yeah, so now import nest underscore async IO, and that's it. If I run this, it should run fine. So yeah, now all the dependencies are imported. Why we are going to use that? FastAPI to make API app, Pydantic to use to explicitly define the data types, pickle to deserialize our model, JSON to convert the JSON strings into text, UVCon to run our FastAPI app seamlessly, then ngrok to get the tunnel public URL, then middleware in order to make the FastAPI app work, and nest async IO to make the app asynchronous. That's it. Okay, so now we are going to define the origins of our app. If we do equal to and do all, it will take all the origins. So now if we do app, but firstly we have to define the FastAPI app. So we will do app equals to FastAPI, and we will call the function. That's it. If I run this, it should run fine. And now if we do app dot add middleware, we will just add the middleware to it in order to make our app work. And now we will add the course middleware, and then we will allow origins. As origins, okay, then we will allow the credentials, allow underscore credentials equals to true. Okay, then we will allow methods, every method to work with our app, like the get post method. So every bit of like HTTP method will work, delete, get, post, everything. Although we only need post, we will allow everything for now to make our app work seamlessly. You can like work more efficiently. We can also explicitly define the get and post method, but it's okay. Okay, so after this, there's one more thing we have to define, and that is the headers. Allow underscore headers is equal to, again, we are going to allow all the headers in order to fully secure our app. And that's it. If I run this, it should run fine. Now, we are going to define a model input through our base model module that we imported from Pydantic. So now we are going to define a class as model underscore input that will take the base model as the inherited one. Okay. And now if what we are going to do is define every bit of column from our diabetes model. So as you can see, in the last cell, I have done every bit of column using the x.column function. Now, what we are going to do is define these here. Okay. So if I do this, it should work fine. I just literally copy pasted it and it should work fine without any errors. Okay, so again I have to like use the indentation, and then what we will do is explicitly define the data type. So as I know, this is the integer, this is also integer, this is also integer, this is integer also, and the insulin is also integer. The BMI is float. Okay, age is also integer, but before that this is also float, and this is also integer. Yeah, so if I now run this, it should run fine. So we have explicitly defined every data type for our model's input. So even if the user like by mistakenly like does age as 5.2, it will not work because our model doesn't allow. Okay, so now what we will do is we will load the model and deserialize it using pick. So now let's do model equal to, let's do diabetes model. Diabetes underscore model equals to pickle dot load, and we will open what we will open this model. We will do rename file, then we will copy everything, Control C, and we will paste here Control V, and we will do read binary. Okay, I hope you guys have understood why we read the binary, because when we are deserializing it, we are just going to like work with the binary sequence of that model in the SAB file, and that's it. Now let's define the post method of the app using FastAPI. So if you know, our app is defined by app, and now we will define the post method of this app. And what will be our endpoint? Let's do diabetes underscore prediction. Okay, in this endpoint we will define a function to predict diabetes. Okay, so now what we will do is define a function to predict diabetes, and let's take the input underscore parameters as model input. So all these parameters will be going here through the model input, and now in this function what we will do is we will take the input data through the input parameters dot JSON. Okay, now what we will do is input dictionary. We will define a dictionary through the loads method of the JSON. So JSON, not the parameters, sorry, dict equals to JSON dot loads, and we will load the input underscore data in it. Underscore data and clear this. That's it. Now we will do a pregnancy equals to for every bit of column we will define this input dictionary method and take the exact column from the, what do you say, or from these guys. Okay, so now pregnancies, if we define it, it should work fine. And now if I do this, then do glucose, and also do glucose here, yeah, it should run fine. Blood pressure, and here let's do BP. Let's here do skin. I'm looking from here, by the way, if you are wondering. And let's do, what was it, skin thickness. Okay, now after that, what is it, insulin. The insulin was insulin, and the order of these should be like same. Okay, don't change them. So BMI, let's do I as small in insulin, and let's do BMI is here capital. Now let's copy this, Control C, paste it here, Control V, and do DPF. And lastly, if we just do this, and lastly do age here and age here, it should run fine. And now what we do is we will convert this into a list. So input underscore list equals to, we'll do peg as for pregnancy, then glucose, then BP, then insulin, then BMI, then DPF, and then lastly age. Okay, and then we will do prediction using our predict function of the model. So prediction equals to, what was it, diabetes model dot predict. We will call the predict function on it, and we will pass the input list as a list. Okay, and yeah, that should do it. And lastly, if, as I said, not the parenthesis, if the prediction's first index, like the 0th index, contains 0, what we will do, we will return person is not diabetic. Okay, let's say the person is not diabetic, and else what we will do, we will return the person has diabetes. Okay, and I'll do this capital, and yeah, That should do it. If I run this, it should run fine. And now the last part. In the last part, what we are going to do is define an Ngrok authentication token, which I will not be showing you because it is my personal token, obviously. What you are going to do is, as I said, to get an authentication token from the Ngrok dashboard. After getting that, we are going to define it as Ngrok auth token, and then we are going to paste it here. If I do Windows V and this, this is my token, and it should not be visible to you, and it should be like hidden within the editing software. While editing, I'll just tell my editor to hide it. Okay, so after it, if you run this cell, your authentication token should be saved at root.config/ngrok/ngrok.yaml. And lastly, we will define the ngrok tunnel. So ngrok underscore tunnel equals to ngrok.connect, and we will connect it with the port number 8000, and then we will print the public URL. So the public URL is visible at ngrok.tunnel.public URL. Okay, then we will do nest async io.apply. That will make this request as asynchronous, and then we will do ubeacon dot run, and we will do app. We will run the app at port 8000. Okay, and if we run this, okay, I forgot a comma here. And now if we run this, as you can see, we have a public URL here, and we have also a local host URL here. Now what we are going to do is we are going to go and make some kind of, again, one kind of Python file in order to like work with our API, public API. Okay, one tip. Now you might be having some doubts that if like this API needs to be run on Colab, once I close this Colab notebook, what is going to happen? Don't worry, make an EC2 instance on Amazon Web Services or like AWS or a virtual machine Azure, or you can just deploy a Python file on Render or Vercel, any kind of deploying site that you need. Just run this code there, give them some environment variable, that ngrok authentication token as the environment variable, and you're done. And that should run infinitely, and whenever you like need to request something from your model, it will just get you that. I hope you have understood. Now we will just work with another Colab notebook here, and what we are going to do is like use this public API to do something which is predicting the output with our predefined, what do you say, the predefined model, pre-trained model to be exact. So let's import JSON here, and let's import the request here in order to access the requests. And if we run this, it should take some time to run and connect to the URL. Okay, sorry, to connect to the instance actually. Now in this we are going to define a URL. So now let's take this URL, public URL, of the tunnel that Ngrok provided us. I'll just rename this to API access point. No, it is not an access point actually, but it's okay. And now let's paste that here. And as you know, in our app, we have defined the endpoint as diabetes prediction. So we are going to copy this. And again, we are going to paste this here. So it will define our endpoint. So if we run this, that is it. Now we will define the input data for the model. Let's say for model. Okay. And we will define it as a dictionary. If we do pregnancies and get our data from this one, okay, this one, as you can see, let's check the result here. The person is diabetic. Okay, so our model should display the person is diabetic or something like that, depending on what we have wrote here. Like, I think it must be same, but it's okay. Okay, like what I'll just do is Control V and Z. Okay. And what I'll do here is I'll just paste this here and then do 5. Then again do glucose as 166. Then I think it was blood pressure. Yeah, it was blood pressure. And it was 72. Okay. Then it was skin thickness. So skin thickness. And it should be 35. Sorry, what I'm going to do? 19. Yeah, should be 19, not 35. I don't know from where did I take 35, but it's okay. So insulin as after 19 it is 175. Okay, after that we are going to take BMI, and the BMI should be in the float, yeah, 25.8 to be exact. Then we are going to take the diabetes that we copied here, yeah, diabetes pedigree function value, which is 0.587. And lastly, we are going to take the age as 51. Yeah, that's it. And now what we are going to do is we will convert this data into JSON. So JSON equal to JSON.dumps, and what we'll do input data for model, we'll pass it, and then we will do response equals to, we'll do a post request, so request dot post to the URL. Okay, so we will do a post request to the URL, doing the data equals to input underscore JSON. We will pass the JSON data. Okay, the request is done, as you can see. And lastly, if we print the response dot text, it should display us that the internet server error. Okay, what happened? Skin thickness, that. Okay, I think we have, yeah, skin thickness, we have done it in the wrong direction actually, and now once we have modified this, we have to run everything again. So again, I'll just define a FastAPI and the authentication token, and then if I run this, yeah, here again we will take this HTTP URL, Control C, go here, paste it here. Okay, no spaces at first. Again, run all of this. Let's again run this. Okay, and now, okay, we have like generated a response. I think it should run now. Okay, again the internet server error. X has 77 features, but SVC is expecting 8 features as input. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we defined 8. And here we defined 8 actually. Okay, I don't know what happened. It should work fine actually. Yeah, I did same thing as before. I'll just copy from my other file if I want to. Okay, let's see. Control V. Yeah. And then server error. I don't know what happened. X has 7 features, but SVC is expecting 8 features as input. I am giving 8 features as input if you are being okay. Pregnancy, glucose, BP, and we didn't do skin here. That's where all things ended. Okay, got it. Yeah, if we stop this and again run this, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 cells and we are done. Again, every time you run the app, you are going to generate a new URL. So yeah, I have to again paste this and with the same endpoint. Again, no spaces at front. And again, let's run this. It should run now. And if I do Control Z, yeah. Now, if we generate a response, yep. And if we do this, internet server error again. Okay, prediction is not defined. Yeah, because prediction is not the word because the the T is missing. My bad. Prediction, yeah. And lastly, let's just stop this. You know, this is the debugging on the way, and yeah, it should run fine now, I hope, because it's the 4th time. And yeah, it should run fine. And let's generate the HTTP link, the public link. If we do Control C here, and please work this time. Control V, run this, again this. The output should be the person has diabetes because the answer was 1. Okay, the person has diabetes. Yeah, so as you can see, we have deployed a model as a public API through Ngrok, and as I said, run this script, Python script, run this as a Python script in any kind of virtual machine or any kind of EC2 instance on Amazon Web Services, and you should be fine. Lifetime API request in your, like, what do you say? You can also like run this as a serverless API actually, as a Lambda function, and it is free for like lifetime. So yeah, I hope you have enjoyed, and I hope you have got some kind of knowledge from this video. I hope you guys are now going to get into doing this stuff, and I hope you guys do deploy your models as an public API and show it to us. Like, if you did, please like comment your public URLs down in the description, or sorry, down in the comment section, and I'll check that out. So I hope you guys have enjoyed, and if you have enjoyed, please hit that like button and subscribe to the channel for more such videos. And this is a throw from Pi Analytics. Peace out.